design paradigm like MVC is to not blur these lines and to adhere to these best practices so that when you start collaborating with someone else, or when some new device comes out, like the newest iPad, which is maybe bigger than the 2 existing iPads, you don't have to change how you're representing your data. You don't have to change any of your so-called business logic, the guts of your program. All you have to do is change or add a new view. And this makes it super easy to deal with things like iPhones and Windows phones and Android devices and all of the different displays or views that a user might interact with. You don't have to touch the essence of your program. And that just makes life much, much easier as your programs get more complex and more interesting. All right. So here is now, how an iPhone application or an iPad application works in more detail than we need for today. But let me go ahead and zoom in on a portion of this. The key feature of this picture is the fact that there's that circle in the bottom left-hand corner, generally known as an event loop. And as you might imagine, if you have an iPhone or an Android device or anything that's a touch screen these days, for the most part, it's just sitting there for the entirety of its life, waiting for you to do something or waiting for something external to happen, like an SMS message coming in or a phone call coming in. So it makes sense that the essence of a smartphone or a tablet these days is just to sit in an infinite loop, waiting for something to happen. And that's indeed what's really happening in some form underneath the hood. So this is a picture from Apple's documentation, the URL for which is at the bottom of the slide if you'd like to read the whole article. And when you launch an application, you tap an icon. The main function gets invoked, which just like in the world of C and Objective-C, independent of iOS, is the first function that gets called. We'll see that there's typically a function called UI application main that's called by default, by convention, just because Apple designed the infrastructure to run that way. And then we load the main UI file, UI being just user interface, so something having to do with the visual aspects of my program. First initialization, whatever that means. Maybe it's loading some of my top scores if it's a game, or maybe it's loading my bank account information from cache, something like that, some piece of data. And now we have a fork in the road, but let's see, let's just go straight down and assume that I haven't written any code yet. We're going to restore the UI state. So if I, for instance, played this game 5 minutes ago, but then had to take a call, maybe I need to redisplay to the user where they paused the game rather than starting from scratch. So that's what we mean by restore UI state. Final initialization, whatever that means for my particular program. And then once we reach this blue rectangle, we've activated the app and just start listening for the user to touch the screen, for a monster to come by on the screen, for a phone call to come in, for an SMS to arrive. We just keep waiting for something interesting to happen. Meanwhile, stuff can happen. And this line going from left to right is pointing at this box that says handle events, where an event is any of the things I just described. Something external triggered by the user or external triggered by the network to which you're connected. Now, meanwhile, we have some slightly more technical detail on the right. This is the last portion of this picture. On the right, everything in this big white box is my code that I've written. So we see in a monospaced font some functions or methods that we'll soon see in some actual code. And for instance, one of the functions up there is called application will finish launching with options. This is a common characteristic of Objective-C methods. They are atrociously long named, but they're very descriptive. And they capture their names describe what their arguments or parameters are. Various methods, which is a nice hand wave there. Application did finish launching with options. So notice the difference. First one is will finish, so it's about to finish launching. Did finish means it's after the fact. So if your code needs to do something before or after that change in state, you have that control. And then lastly down here, application did become active. So if you have ever implemented a game, this kind of implies that you can, for instance, immediately resume the game because somehow or other Apple is providing you with these hooks into interesting key events. This is quite like we saw in JavaScript with the world of DOM. On click, on submit, all of the interesting things that can happen in JavaScript can happen in similar spirit in the world of iOS. So this white box is what we're going to start writing today. And Apple has written all of this stuff for us and essentially just allows us to hook into this event loop, waiting and listening for interesting things to happen, just like JavaScript and jQuery allow us to do quite readily in the world of HTML. Yeah?
Event loop, say a tap on the button, will the event affect for the run in its own thread? Or will it effectively block the event loop?
Good question. Short answer is it depends on what kind of action is and where it happens. For instance, if you have a program that's running and you get a phone call, Apple's threads can take higher priority and therefore interrupt your program and actually show you on the screen who is actually calling. So multi-threaded, yes, but not necessarily in the sense that you can't continue running while that phone call is in progress. So there are certain design paradigms that Apple adheres to that forces your threads to go to sleep when more important things happen. And this is in contrast to the world of, say, Android, which lets you do a lot more. And the argument long-standing for Apple has been that this way they can police battery life better so that you don't have some thread in the background just churning and churning away. But the price we pay is that if you run, for instance, the Gmail app on your phone, you can get notifications and be informed that you have new mail with the little badge number being incremented. But if you want to actually check your mail, you have to load Gmail, refresh the screen, wait a few seconds, and then see your email. And I bring this up as an example because it drives me nuts. Whereas the built-in mail application has is more tightly coupled with the operating system and can actually do all of that in the background in its own thread. All right. So UIKit is where we begin our look today. And UIKit is just the user interface related SDK that Apple provides to the world, software development kit. So these are some class names that will quickly become familiar to us, some more so than others. And they describe different classes that allow us to do different things. UI application is the class that describes an iOS application. UI application delegate is similar in spirit, and we'll come back to delegation and protocols later today. UI view describes the aesthetics of a program. It's a class that represents something that's on the screen. Maybe it's a rectangle, maybe it's a button, maybe it's a text field, so something like that. UI view controller is unfortunately named. Apple calls controllers view controllers. So they are distinct. View controller is the C, UI view is the V. View controller is, again, just a C, not a V. It's the brains of our application typically. And UI window is just a class that represents the rectangular piece of glass in some form that your application is going to run inside. So let's go ahead and write our first application. It turns out we have different starting points that Xcode provides us with. We don't really have to use any template code that Apple provides, but you'll typically find that it's a great way to get started quickly, even if you just start with an empty application. So let's do this. Let's see if we start by loading Xcode here and going up to the File menu and going to New Project. So not New File, but New Project. So I get a whole bunch of folders and a whole bunch of files for free. Notice that we've got some organization here. And last week, you may recall poking around with OS X because we just needed some simple Objective-C programs, not necessarily iOS. Tonight and hereafter, we focus only on the top half of that menu under iOS, where we have an application category, framework and library, and other. Most everything we'll be interested in for now will be under iOS application. So here are those same template names we saw a moment ago. And if you're familiar with an iOS device, you probably recognize some of the design paradigms here. The master detail view looks like it has a little menu on the left-hand side and then more information on the right-hand side, like the built-in mail application. OpenGL game refers to a graphics-based game. Page-based application means something that has that sexy page curl that happens from the bottom up. Single view application is a place we'll spend some time today, since it just allows us to have some basic sample code and to get started quickly with a user interface of our own. Utility application, which is something like the weather or the stock application, super simple, but typically have a button that allows you to flip it around to see some settings. And indeed, that's the template you'll use for the next project starting Wednesday onward. And then the last one down there is tabbed application, which is also a common paradigm, at least in iOS 6 and prior, where you have got some big icons at the bottom that toggle state among different portions of a program's functionality. So let's do something super simple like empty application. And according to the instructions, this template provides a starting point for any application. It provides just an application delegate and a window. So let's see what this actually gets us. And what we'll do today is spend some time in particular on what the sample code is that Apple provides, not because it's interesting, but because it's representative of how you might write your own applications. So here we have knowing a number of prompts. I'm going to go ahead and just call this test. My organization name can be whatever I want here. I'll say Harvard University. Company identifier, you just need a probabilistically unique string, really, so that if you push an app to the App App Store. It's distinct. We'll go with edu.harvard, which is a common paradigm in the Java world for package names. If we own harvard.edu, presumably no one else in the world is going to use that same prefix for their applications, but it's just a human convention. Class prefix, I'm going to leave blank because it doesn't matter. Devices. For lecture, I'm going to typically choose iPhone, really just so that it fits nicely in the screen so we can see everything. And then there's a few options here. Core data we'll come back to in the future, but it has to do with a abstraction layer for storing data in the equivalent of a database. Use automatic reference counting is that memory management feature I alluded to earlier.